In this video, we are going to learn dual write problem. Dual write problem occurs when application needs to change data in two different systems, for example, a database and a message queue. If one of the write fails, it can result in inconsistent state. This is the typical case when you use a local transactions with each of the external system's operations. For example, when an application needs to persist data in the database and send a message to the Kafka for notifying other systems. If one of these two operations fails, the data will be inconsistent data and these two systems become inconsistent. Here you can see the problems. This can lead to problems such as data loss or corruption and can be difficult to resolve without proper error handling and recovery mechanism in place. So that means dual write can be hard to detect and fix. Here you can see an example of dual write problem. In this example, we will illustrate create order use case in microservices. That means when create an order request comes, we want to change data in order database with creating a new record and also send an order created event to the event bus like Apache Kafka. Both operation is handled with two different local transactions that cause dual write problems. As you can see the image, we have a order microservices, client application send a request which is the create order, and in the order microservices we have two main operations. The first one is write order table, which is the create any order item in the order table into the database, and after that order microservice is going to publish event to the create order event in order to start order fulfillment process to notify other microservices which subscribing the event from the create order event into the event bus, which could be the inventory, shipment, and so on. So this is the dual write problem, and let me explain why there are no simple solution for this problem. If order microservices write to its database and then the publish event to the queue for notification microservices, there is still a chance the application won't work reliably. While order microservices write to its own database and then send the message to a queue, there is a small probability to the application crashing after the commit the database and before the second operation, which would leave the system in an inconsistent state. So that means we are performed successfully order create operation, but somehow we can't publish the event and that makes an inconsistent state. If we decide to change order of these two operations, like if you publish the message before writing the database, there is also a possibility of database write failing or timing issues where notification microservices received the event before ordering microservices has committed the change into its database. In both cases, it becomes dual write problem to database and a queue, which is the core problem we are going to explore. So that means whether we have run the first and second step or second to first step, it both become a dual writes. So how to avoid dual write problem in microservices? When we build monolithic applications, we used distributed transactions in order to avoid this situation. Distributed transaction use the two-phase commit protocols. It basically split the commit process of the transaction into two steps and ensures the ACID principles for all systems. But we can't use two-phase commit transactions when building microservices. These transactions requires locks and don't scale well. So that means we should lock the databases and it is also not good for scaling. They also need all involved systems to be up and running at the same time and it is not obey the microservices characteristics. So how to avoid dual write problems in microservices? The solutions are transactional outbox pattern and CDC, which is the change data capture principle. Also, the best practices is that we can use the outbox pattern with Red Hat Apache Kafka and CDC using the Debezium in order to avoid dual write problem in event-driven applications. Or we can use new databases, new SQL databases like CockroachDB, which has built-in change data capture feature. But before that, let's understand what is the transactional outbox pattern.